Okay, hi guys. So I thought we should go and make sure we talked about the second one where we have our denominator has repeated linear factors. So with all of these partial fractions, we know to use partial fractions because our denominator has a larger degree than our numerator. Remember, our numerator in this one has an x squared term and our denominator has an x cubed. So we go ahead and we start by factoring that denominator, which we already did. And what makes the second one special is that we have this repeated factor here of x plus 1 squared. So what's tempting a lot of times is that we want to set it up and we remember to use this denominator of x and we remember to use this denominator of x plus 1 squared, but sometimes we forget about this x plus 1 denominator. So the caution is in the setup. If you have a repeated factor, so like x plus 1 squared is repeated because it's squared, we need to have the x plus 1 squared and then the x plus 1 like to the first power. If it were cubed, we'd need an x plus 1, an x plus 1 squared, and an x plus 1 cubed. So just be careful there. Once we get there, it's going to be the same process. So now we want to solve for a, b, and c. And this is going to be true for all x values. So we're just going to start by multiplying both sides. So let me erase this. This was just a discussion we were having in class about how we could kind of think about it in terms of regular numbers instead of the algebra, in this idea of undoing the fractions. So I'm going to go ahead and rewrite this one. Let me switch this to this color. This 5x squared plus 20x plus 6. And then that's over that x times x plus 1 squared. And we set it up as a over x plus b over x plus 1. And if you've watched example C, you'll notice in example C we have a factor that's squared. The difference here is our factor is linear, which means our numerator can still be just a constant. So that makes our life nicer. So remember, first thing we do here is we multiply both sides by that denominator so that we can start getting rid of the fractions and dealing with just our numerators. So I always like to go ahead and write out all of this so that I tend to lose fewer things. As you may have noticed if you've worked some homework problems already, it's really easy to make algebraic mistakes in these problems. It's actually significantly easier than calculus mistakes. It's usually a sign error. So we go ahead and we reduce, right? This x reduces, one of these x plus 1 terms reduces, and then this x plus 1 squared reduces. Whoops. So that we get c times x. Okay. And now we're at the point where we can, we want to start solving for a, b, and c. So what's really nice here is this is true for all x values. And why that's lovely is because then we can just pick any x value that makes our life easy. So one of our favorites is anything that will make these terms be 0, right? But let's start with x equals 0 for our first one, because x equals 0 always makes evaluating things be easier. Make sure that you're showing plugging in, especially being online and all of that jazz. We want to really communicate our thought process clearly. So show your plugging in. And then once you show your plugging in, then of course it's easier to see that like this term is going to go to 0 and this term is going to go to 0, this term 0, this term 0, which leaves us 6 is equal to, whoops, I wanted to change back to that other color. Sorry, get my eraser. Which leaves us with 6 is equal to a. And so now we have a. Now we just want to do this again. So observing this, a good choice for x would be -1, right? Because that's going to make that x plus 1 term be 0. So same thing, we'll substitute in, we'll turn all of our x's into -1. 5 times negative 1 squared plus 20 times negative 1 plus 6 equals a times negative, well, actually, we know what a is. So since we know what a is, we should go ahead and plug it in. It doesn't matter because this negative 1 plus 1 is going to be 0, and it's going to cancel out that term. But it's okay. We're going to go ahead and show that we know it and that we're plugging it in. And then we have c times negative 1. Okay. So negative 5, nope, positive 5 minus 20 plus 6 equals, let's see, that's 6 times 0 squared. Well, really minus b, right? B times negative 1 minus b times 0, which is just going to be 0 minus c. Over here, negative 5 plus 20, negative 15. Negative 15 plus 6, that's going to be negative 9 equals negative c. Oops. Again, eraser. Negative 9 equals negative c, or c equals 9. Now, we have a and c, but we can't, there's no more numbers that we can choose that are going to make this be 0. So just pick your favorite other number. So like I said, we can really choose anything. I'm going to use x equal to 1 because we haven't used that yet. And it doesn't seem like it's going to make my life difficult or anything. Sometimes I'll choose even numbers if I think that there might be fractions or something like that. Otherwise, 1s, negative 1s, 2, negative 2, 0, those are all first choices, right? All right, 1 plus 1 squared plus b times 1, 1 plus 1, plus c, and c gets multiplied by just x, so c times 1. 5 plus 20 plus 6 equals 6 times 2 squared, plus b times 2, or 2b plus c. Oh, wait, we know b. No, we know c. Just kidding, we know c. C was 9. Let's plug c in. That would probably be smart. Okay, so it was 9 times 1. Okay, so over here, let's see, that's 31 equals 24 plus 2b plus 9. If I subtract 24, that's going to be 7. And if I subtract another 9, that's going to be negative 2. Right, that's negative 33. Negative 2 equals 2b. Solve for b, and we get b equals negative 1. Now that we've found a, b, and c, we just go back and we rewrite our fraction as the sum of fractions. So rewrite fraction as the sum of these simpler fractions that we have, these partial fractions that we have. So what I mean by go back is I go back to basically this line right here, right? Except now I know a, b, and c. Okay, and I'm going to write this with my integral. So my original problem, I'm going to use a little bit of copy paste for us. My original problem was this 5x squared plus 20x plus 6. So I'm going to copy that and take it down to the end here, and I'm going to paste it. Beautiful. Okay, now we said that that was equal to, and since it's integral, I'm going to stick with the integral, a over x, b over x plus 1, and c over x plus 1 squared. So a was 6, so 6 over x dx, plus b was negative 1 over x plus 1 dx, plus, and then c was 9, right, over x plus 1 squared dx. Yes, c was 9. So then this is nice because now it's just a matter of integrating each of these. I often will move my my coefficient out in front, right? 6 times the integral of dx over x minus the integral of dx over x plus 1 plus 9 times the integral, and then this, it's always good to rewrite as x plus 1 to the negative 2. And we know how to integrate that, right? Add 1 to the exponent there. 6 natural log of absolute value of x minus natural log of absolute value of x plus 1 plus 9. And then this is going to be x plus 1. Add 1 to the exponent, negative 1. Divide by its old exponent, so it's going to be minus 9. Whoops. Minus, I promise my pen was minus 9, and then plus 2. All right, so let me know if you guys have any questions. Hopefully that helps a little bit, and we will be done. We will be on to L'Hopital's rule tomorrow. All right, have a good night. If I can figure out how to stop my computer.